So, assalamu alaikum, everyone. For today, as you know, that our topic is databases. Since it involves a lot of new concepts, we'll start right away. All right, so we'll be talking about databases today. और आपको मालूम है कि ये जो database का concept है, it is about storing data. ठीक है, आजकल तो obviously there's a lot of data around us everywhere. ठीक है, whenever we enter into any kind of transaction, whether at home or at school or at work, we generate data. Even when we go for shopping these days, we generate data. We have been generating data, have always generated data, but the only difference right now is that we are capturing more and more data because more and more of our transactions are through digital means these days. But even before the advent of social media, where all transactions and e-commerce, where most of the transactions happen online, there we used to store data even before that. In case of Pakistan, for example, we have an organization called NADRA. It's a national database registration authority that holds data for all Pakistanis. Right? So this data has to be stored into a computer system in a way that we can access the data whenever we want. We can ask questions, whatever questions we want to ask of this data and get answers. And we should be able to modify that data, for example, add more data or delete obsolete data from it, or maybe make some changes. So these are three operations normally that we do. We add new data, we delete data that's not needed anymore, and we modify existing data in some change the values a little bit. Besides that, another very important thing that we want to do with our data is to protect it and secure it from loss or damage or unauthorized access. We don't want anyone to steal our data. We don't want anyone to go and modify our data without our consent and without our knowledge. So this aspect is called the security data. So whenever we store data on a computer system, we need to be very sure that the data that we are storing is authentic. It has not been changed in any way, right? Because the integrity of database is very important. Otherwise, we won't be able to trust the answers that come from our computer system. Right, so this is the concept of database. Let's see how computers store data. So before this concept of a database it came along, there used to be a concept called files. And talk about files now. So what is a database? We can understand about databases if we compare them with an older system in which we used to store data, and that is the file system. So file system is a system where we have one record per entity in a file. So for example, if we want to create a student file, right? And we want to store data about students. So there will be one record for each student in that file. So if I have like 200 students in my class, there will be 200 different records in the file. So I'll open the file and I can flip through that file to get to the right page, and then I can read all the information on that page. So all the information on that page would be one record for one student, right? And there will be a lot of pieces of information on that page. For example, there would be a name, student name, and it would be on every page. Like for every student, there would be a box in which the name of the students there. There would be another box in which we will have something like the ERP number. There will be another box on the page where we'll have something like address of the student. So depending on what kind of file it is, is it an academic file or a personal file or sports file? Depending on that, the information would vary for each student. I mean, for every student, it would be the same, but in different files, we will have different information. In a sports file, we'll have a sports-related information. In academic file, we'll have courses-related information. In personal file, we might have things like phone number, address, name of parents, etc., etc. So a collection of data that is multidimensional in the sense that that internal links between entities make information accessible from a variety of perspectives. I'll explain this a little bit more. It's a bit complex right now, this statement, but I'll come back to this when we have developed our concepts a little bit more, so that we can understand this these two sentences on your screen in a better way. So let's look at a file that I was talking about. So this is a file over here, right? So in this file, you can see there are multiple lines. I was talking about a page for each student, but sometimes it's just one line, right? So this is one line. This is probably the telephone number of the person. Then you have the name of that person, and this might be maybe the date of birth of that person. So there are three different types of information. Over here, we have a phone number, we have the name, and we have date of birth. But this pattern is repeated for all the people in this file. It might be an employee file, for example, for an organization, right? So this for the first employee, we have their phone number. For the second employee, we have the phone number, and for the third employee. And there will be as many lines in this file as there are employees in that organization. So this is an example of a personal file, right? And in this file, you see this is made up of record. A record is for one employee. There's one line is one record over here, because it belongs to one one person. So all the data or information about one person is in one record. So there's one record for one entity. In this case, it's an employee. And before that, I was talking about students. So in case of students, there will be one line for each student. And this line would have name, ERP number, address, and so on and so forth, right? And this record is made up of fields, right? So for example, over here, we have a couple of fields available. So this is one field that contains the last name. So it's called one field. So these boxes that I was talking about on a page, in database terminology, we call them as fields. So each field has its own type of information, right? And you can see that some of the fields over here on this screen are numeric. It means they contain numbers. And some fields are alphanumeric, that they contain alpha letters and numbers. For example, the name is an alphanumeric field. And finally, the last field is kind of a date field. Date field is also a number field, but it is a special type of number field because it follows a certain format. It also has like hyphens in it, and that's why it's you can call it a not purely numeric field, but you can call it alphanumeric. It depends on how you store data in the file, and there's a difference in the way you store data in the file and in the way you display that data when you print it out, right? So you can print out the same data in different formats. For example, when you're printing this, if this information is in their file, you can probably print name first and then other fields, or you can say, okay, I'll print the date of birth first and then I'll print all other fields, right? So you can shuffle this order when you generate a report from this database or from this file. It doesn't have to be exactly the same way it is stored, because when it is stored, it gets physically stored on your hard drive or a magnetic tape or optical drive like CD drive or somewhere in the cloud, something like that. So the physical storage is obviously in binary format, as we discussed in the beginning of this semester, that all information there are computer stores or processes. It's actually in the form of binary numbers. And we see it over here that the field is actually composed of characters, right? So this is an easy way of describing, for example, the size of the field. We can say, okay, the last name should be 20 characters long, right? So because we know, we, for example, assume, we don't know, but we assume that most of the names would be less than 20 characters in length. There might be someone whose name is longer than that. But when we are designing this database, we'll have to make some assumptions. We cannot like say, okay, maybe somebody has a name that is 200 characters long, so let's make the size of this field as 200 characters long. The problem with that approach is that most of the time this field will remain not fully utilized. Only 10, 20 characters will be used, and all the other 190 or 180 characters will be left blank for each employee. So if we are storing data about a lot of employees, a big organization maybe has several thousand employees, so that space will get wasted, will be wasted for all the employees. So it's not a good use of your storage space, right, for making that assumption, because very rarely will you get someone whose name is so long. And then there is an additional disadvantage, is that maybe somebody comes along whose name is 210 characters long. So all this data that you have, this storage space that you have saved, that strategy will go waste in this case. Right? So that's why it's not a good strategy. So what we do is we make a good guess. Okay, normally, generally, it's 20, right? So in that case, we won't be wasting much space in that case. And if somebody comes with a longer name, we can handle that exceptionally, right? We can say, okay, well, we only have space for your first 20 characters, and we will assign you a unique ERP, and we'll identify you through that. There's another type of databases where you don't have to fix the size of the field in advance. But these are more advanced type of databases. We'll talk about them later. But right now, we'll start with fixed size databases, right? It's because these are the simplest ones. And when we design a database, we design all the fields in advance. Okay, our database will hold the name, it will hold the ERP number, it will hold the mobile phone number, it will hold the email address, and maybe 2 email addresses, and so on and so forth. So we decide upfront all these, we make all these decisions upfront, and then we go ahead and design the structure of this database, and then we start filling in data as a new record comes in. We type in all the information for that particular student or for that particular employee, and then we take the next and enter that, and then we store this. Once we have entered all the data, it gets stored in the database, and it remains there in a safe and secure manner. And only we have a system called a database system. Okay, so database is a collection of files, right? So this is a hierarchy over here. So at the bottom you have characters, multiple characters make up a field, and in a record there are multiple fields. For example, over here we have 3 fields in one record, and then we have many records in a file, right? It depends on how many employees or how many students there are. If it's a small class, just 50 students, then there will be 50 records in this file. If it's a large organization, there might be 5,000, 10,000 records in a file. And in a database, we have multiple files, and each file will have a different structure and different type of information in it. Because the personnel file will have personal details, but the department file will have information about the departments, not employees, but how many departments there are in the organization. What is the name of that department? What's the location of that department? Who is the head of that department? So all that's information about the department. What is the size of the department? what is the location. These kind of things will be the department file. Then in the payroll file, there will be, we want to store all the information that we store in the personal file, which includes like the address and phone number and email address, but we'll only store the identification, for example, ERP number, and then we'll have other information like what's the salary, whether the person has obtained any loans or advances, and those kind of things. So what is the tax? So this is a different type of information which will go in a different file. So one database will have multiple files, and each file will have a different structure, and it will contain different information. Now, in a file-based system, what happens is that we have for every different purpose, we have a different file. For example, the payroll file will have payroll data, employee file will have employee data, inventory will have information about goods and products that are stored in our warehouse, like how many items are there, and how many items of each type are there, where they are located, what is their bin number, and where exactly are they located, and what is the price. So all the information about items would be in the inventory file. And when we make a sale, there will be another file which will record sales. Okay, when was this sale? Who bought this item? At what price? Who was the salesperson, etc. So all this information would be in another file. Now, each of these files you can see is owned and controlled by a different department. For example, the payroll, this information is actually used by the payroll department because they are the accounting people. They deal with money. And there's a marketing department. Since they deal with sales and customer relationships, they have their different information. So in an organization, different departments have different functions, and they make use of different type of information. So each department can have their own file. Now, in case of a database system, all the data is stored in one big database, right? Instead of having different files with different ownerships and different rights, who can access, who can modify. So whenever we store data, we also have to deal with issues like who is going to add data to this file, who is going to delete data, who is authorized to make modifications, etc., and who is responsible for its security. But in case of a database system, all the data is stored in one place, and everyone has access to a subset of that data, and no one gets the access to the entire database, except for maybe the administrator. But different departments will just go and access their own data. They will not go and interfere. And this access is controlled by a system called database management system. So we'll talk about this database management system in our next slide. But the difference that you see between a file system and a database system is that in a file-based system, different data is stored physically in different files. And they may be on different computers, right? Marketing people might have their own computers, and they'll store their own data on their own computer. And payroll department will have their own computer maybe, and they'll store their data on. And the programs that the software that you write to access that data, you'll have to have a different program. So marketing department will write their own application that or have their own program that will control all the data that they have. And payroll department will have their own program that will control their data. And every department will have their own program that will control their own data. But there is no integration, which means these programs are not aware of what other program is doing. These programs don't talk to each other. There's no provision where data can be sent from one program to another because it's on a different computer, it's on a different department, it's written by a different programmer. They have made their own conventions. For example, the payroll record, they say, okay, we'll have 20 character for the name field, right? And the sales department might say, okay, but we'll have 30 characters for the name field, right? So because they don't talk before they design their files. So the payroll department says, okay, we'll keep the first name and last name in two different fields. Okay, there will be one field for first name and there will be another field for the last name. But the marketing department, for example, says, okay, we'll just have one field in which all the first, middle, and last name all would be in the same field. So there will be one field for the name, whereas the payroll department may decide, okay, we'll have three different fields for names. So one field for the first name, one field for the middle name, one field for the last name. And then there might be some other ways of storing data, right? Maybe for example, in Pakistan, we don't follow this convention very. We have our own conventions of naming. How do we construct our names, right? So it might not be the first name, last name system. We might have a different name system, different families would have different naming conventions, right? So on and so forth. So, but in a database, all these decisions have to be made at once at the beginning, and then all the departments will follow the same rules because the data is integrated. The name is not replicated in all the files, right? The name is stored there just once. It's not that the customer service department also storing the name, payroll department also storing the name, personal department also storing the name, purchasing department also storing the name, marketing. It's not the case. The name is there in the database and stored just once, and it's not replicated, and it's the same for all departments, right? Another issue that might arise in a file-based system is that suppose somebody says, okay, I have changed my phone number, right? And they inform the marketing department that my email address has changed or my phone number has changed, but they don't send this information to purchasing department or personnel department or payroll department or someone. So what will happen is that one department will have updated information and the other departments would have outdated information, and there will be a lack of consistency, right? So one department will say, okay, this is the phone number, and the other department will say, this is the phone number, and they might not match because one is new and the other one is old. But in a case of a database system, if somebody tells the marketing department and they change, then it will be changed for everyone, right? Because it's stored on only one place and everyone is coming to the same place to access the value, right? So if one department makes a change, that change is reflected for all departments because they're all accessing the same place. So these are some of the different things that happen. For example, in a file-based system, what I was saying you was this: you have each department has their own data. Over here, it's in yellow rectangles. This is the data. They put it their own files. Now the file structure would be dependent on how their programmers have designed it. They might say, okay, we'll have date of birth first, and then first name and this last name. Then other department might say, okay, we'll have first name first, and then last name, and then date of birth. The third department might say, okay, we don't want to store date of birth. We are not interested. We just name is enough for us. So each structure of each of these files would be different, and there will be different programs because the program has to know what is the structure, right? So if there is no date of birth over here, the program cannot like just say what's the date of birth, because it's not stored here. So there has to be a link between the program that accesses this file and the structure of this file. So there has to be some kind of link between the structure of the file and the way the program works. And then the program will generate its own report. So as you can see that this system is replicated in each department. They have their own data, their own files, their own programs, and their own reports. But these programs or data, they don't, some of the data is replicated in these. For example, the name would get replicated in all of these. Some of them might get replicated in some, but not all. For example, date of birth might be present in the first and second, but not in the third and fourth one, and so on and so forth. So this is what happens in a file system. So these are the drawbacks, as I was talking about duplication, right? The name gets duplicated in all the files. Inconsistency happens when you update half of the files and the other half of the files have old data or the wrong data. So there's an inconsistency. Then there is program and data dependence, because the data, the structure of the data is actually defined by the program, right? Because the program creates the file, right? There is a line in the program that says, create this file with this structure, and then you start showing. So each, there's this link between the type of instructions you want to write and the type of data that you want to store. There's a link or dependence between them. So these are some of the drawbacks of the file system. Conversely, these drawbacks become advantages of database system. So you have more data integrity, means less inconsistency, more information, because when you combine data from various fields, from various departments into the one place, you can generate more information from that, right? Because otherwise you only have a limited set of data and you cannot manipulate that extensively. But in case of a database, since all the data is present, you can shuffle it in different ways to get more information. More control of data, because there's one database administrator who's looking after the data, so they have more control over what gets in the database, who gets the who gets the authorization to access that data, who gets to modify the data, who can change data and who can delete data, things like that, right? So they have better control. And more information leads to better decision making, obviously, and improved security. We are talking about security because everything is at one place, and there is an additional layer between data and programs, which is a systems software called database management system. I mentioned about that in the beginning of the lecture. We will talk more about it later, but it's a specialized software called database management system. So a management system, this is kind of a layer around your data, and all the programs access the DBMS, and the DBMS then retrieves data and sends it to the program. So there's improved, in this case, there's improved security and also standardization of data, right? It doesn't mean that one department is keeping first name and last name separately, and the other department is all keeping all the name information in one field, or maybe one department is calling it a pen, and another department calling it the writing instrument, right? So there might be when you use database, then these conventions become standardized, right? Everyone has the same standard of data. So these are the advantages of database. This is the diagram that shows the same approach that you saw in the case of a file system, but this is different. This is the database approach, and you can see that we have a big database over here, and all the data is present in the same database. Payroll data, inventory data, other data. And this is the layer I was talking about, the database management system. It's a piece of software, it's a specialized software that provides security and access and everything. And the programs basically make requests to this management system over here, and the database management system controls data over here on this side, the database. So this is the database over here, and this is the management system, database management system, and different applications like the payroll application and inventory application. They send their requests for data to DBMS, and DBMS provides them with the data. Because different programs will require different type of data. The payroll program will need payroll data, right? Inventory program would need inventory data over here. So the DBMS will take care of that who gets what data, and they don't interfere with other data. And each program can then generate their own reports. So different users will get different reports from the same data. So what are the disadvantages of a database system? Obviously, it's more expensive. Now, obviously, its prices are falling, but also becoming higher at the same time because of the new capabilities that come. So the newer version is very expensive, but the older versions get cheaper, right? So depending on whether you want to go with the latest technology or with the old technology, but usually you go with the latest technology, that's why it's more expensive. You also need more expertise to understand the database management system, how it works. So it has its own learning curve, the DBMS, right? For example, the Oracle database. Many of you have heard of Oracle database. You get certifications in becoming the administrator for that. तो DBA का अपना जो है एक certificate होता है, and you can learn that and become certified database administrator. Then there are other type of databases available. Then there are open source databases also available, and each will require its own expertise. And so I was saying that, okay, this the payroll department will only see the payroll data, and this will not be visible. All the other data will not be visible. Only some portion of this data will be visible to the payroll program. So technically, this is called as a schema, right? So a subset of data is called as the sub schema over here, right? So this is just the structure of data that would be visible. It is that portion of data that will be visible to a particular application, and not the entire picture. The whole picture is called as the schema. So a schema is the overall structure of the database, right? So when we were talking about files, we were talking about this structure, right? You said, okay, we'll have the date of birth, and we'll have name, and we'll have address, and we'll have phone number. So that's the structure. So this structure in the case of a database is called as the schema. Well, a schema obviously has all the fields in it, not just used by one file, but all the fields that are in all the files are there. They are in the schema, the big picture. And the different particular applications don't get to see the whole picture because it's not advisable, and obviously they don't need. Say they only look at what is needed by them. So they don't need rest of the data. They only need to see a small portion of the data. So that small portion is called the sub schema. So though that application would think, okay, the structure of the database is that there are just these three fields in the database. All of the fields will be invisible to that application because there are only one sub schema is visible to one application. So this is the difference between schemas and sub schemas. This is just an example. University database will have all the information, right? Name, address, phone number, academic, everything. But the registrar will have a sub schema in which they can see only who's the faculty member who is supervising that student, but they're not able to see the past employment history of the faculty member, because the faculty member will have all that information present in the university database, but that would be maybe relevant only to the payroll department, accounting department, the finance department. So there will be different roles in the university, and different people with different roles will have different access or different sub-schemas available to them. Conceptually, this is what we were talking about. We saw the same diagram in a different form a few slides back over here. See, so it's the same diagram. This is the data over here. This is the core data. Then you have the DBMS. And then you have applications, and then you have users, right? These are the 4 layers. And you see the 4 layers over here also, but in reverse order, right? So you have the data over here, DBMS over here, application over here, and users over here, right? So this is conceptually how users are separated from the real data. So the users have to first invoke their own application. For example, the payroll application will make request to the DBMS, and DBMS will control the actual data. Now,
Sir?
Yep.
Sir, could you please repeat the last 5 minutes? My light went out.
So I'm recording this, and I'll upload this right after the class. And
Okay.
all right. So this what I was talking about databases. Now the actual data inside a DBMS, the way the data is actually stored is stored according to the data model. So this is something different, right? This is a new concept of a data model. So what is the data model? We have 3 data models we'll talk about. One is the hierarchical, the other one is network, and the third one is relational. So since the relational database is most obvious to us, and we are we are most familiar with relational database. So I'll talk about relational database first, and then I'll talk about the other ones. So I'll focus on relational databases, right? So relational databases is the more familiar name for relational database is a table or a spreadsheet. A spreadsheet is a term that we are familiar with. That's why I'm using it over here. But a spreadsheet has its own data model. The data model of a spreadsheet is a table. And in database, it's called the relational model, right? So these are different terms, but they basically, this means that the data is stored in form of a table with which we have rows and columns, where each row is one row is equal to one record, right? And one column, this column, vertical column is equal to field. So if it's a student table, right, each row will correspond to one student. The first field or the first column or the first field might be the ERP number, right? And the second column might be the name of the student. So this will get replicated throughout the table. So every row will have ERP number as the first column and name as in the second column, right? So this model in which we store data in form of a table which contains rows and columns, and each row corresponds to one entity or one record or one student, for example, and each column corresponds to one field of that record, right? This model is called as the relational model. The table model is called the relational model. There are 2 other models called the network and hierarchical model. And let me see if I have many examples. Okay, so this is the example of the hierarchical model. Let me share it again. All right. So the data is in a hierarchical model is not stored in the form of a table, but it is stored in a form of records in which each record has on different records as its components. Okay, and each component has its own. So it's a kind of a tree structure over here, right? So all the data about employee 1 and employee 2 and all other employees that are in department A would be in one record called department A, right? And similarly, there will be another record called department B, and another record called department C, and there will be as many records as there are departments. And if each of them could be part of a bigger record called project. So this is different. There are no rows and columns in this conceptual model. Conceptually, it's like a tree, right? So this is called a hierarchical database. This is not very common and popular these days. It's there just to tell you that these exist as an alternative to the table model. And then you have also the network model. The network model, the only difference between network model and hierarchical model is that these lines can have different connections, right? So in a tree, what you see is you only see that each node has only one parent, right? This is the key difference between a hierarchical model and a network model is that in a hierarchical model, each record will have only one parent. But if you have a network model, each record can have multiple parents at multiple levels. So there's link between it's something like the mesh topology that we studied in our lectures on networks. So we also have databases that have a kind of a mesh structure, and we call them as network structure over here, or network data model. So we won't be spending any time on studying these two. We'll only be spending our time on studying relational databases. So like I said, the relational database is like a table, and we call these tables as relations when we are using the database terminology, right? So on the screen you see is a relation. I'm not calling it a table right now. I'm calling it as a relation because this relation has rows and columns, and each column is one field, and each row is one record, right? So we have records and fields, and this table is called as a relation, right? Or you can call it a table also. These are like interchangeable terms. We call it a relation just to let you know that why is this model called as relational. It's called as relational because relation is actually a term that comes from mathematics. If you remember that when you were studying sets, you might have come across this term relation, right? Relation. We have relations between two sets, right? And which one set is a member of another set. There's a kind of a relation between two sets. So relations, you can think of this table also as a set, right? And each set has different type of relationships within each other. So Bharat, this is only to tell you that why the term relation is that comes from relational algebra. But for normal everyday practice in the database terminology, you can also call it as a table. And you see this table. Now, what you see in this table is something peculiar, which is that you see there are the first two rows or two records. They both belong to the same employee, right? Employee ID 25 by 15, 25x15. It's the same employee, but what is different is that this employee is working on two different jobs, right? Maybe it has two jobs. So it's working on job F5 over here, and it's also working on job D7. So they're the same employee, Joe Baker. ये देखें आप ये same employee है, उसका same address भी same है, और उसका social security number या जो ID ERP number होता है वो भी same है, लेकिन वो उसके पास different jobs हैं, दो jobs हैं, एक का नाम है F5, एक का नाम है D7, और एक जॉब का टाइटल जो है वो है फ्लोर मैनेजर, दूसरे का नाम, डिफरेंट टाइटल्स, डिफरेंट जॉब्स के डिफरेंट, यानी कि जो रिस्पॉन्सिबिलिटीज हैं इसके पास दो रिस्पॉन्सिबिलिटीज हैं, फ्लोर मैनेजर भी है ये और डिपार्टमेंट हेड भी है, और उसमें जो है हर काम करने के लिए अब कुछ स्किल्स चाहिए होती हैं, ठीक है, तो वो स्किल्स के फ्लोर मैनेजर को जो है स्किल्स चाहिए होती है FM3, ये फ्लोर मैनेजमेंट स्किल है, और ये डिपार्टमेंट को हेड करने के लिए लेट्स से नॉलेज 2 स्किल चाहिए, वो यहाँ पे है। फिर ये कौन से डिपार्टमेंट में ये कौन से डिपार्टमेंट का ये हेड है, ठीक है, सेल्स डिपार्टमेंट का हेड है ये पर्सन, ठीक है, और डिफरेंट टाइम पे जाहिर है ज्वाइन किया, ठीक है, इसने स्टार्टिंग डेट डिफरेंट हो सकती है। तो ये टेबल एक ही है, लेकिन इसमें रोज आइडेंटिकल नहीं है, रोज डिफरेंट है, लेकिन उनके कुछ फील्ड्स जो है वो आइडेंटिकल है, बिकॉज दे बिलोंग टू द सेम एंड या सेम। इसी तरह से आप यहाँ पे देख सकते हैं कि ये जो दूसरा लास्ट एम्प्लॉय है जेरी स्मिथ, इसके पास भी जो है आप देखें कि एम्प्लॉय आईडी सेम है, नाम सेम है, एड्रेस सेम है, ERP एड्रेस सेम है, और जॉब आईडीज भी सेम है, स्लाइटली डिफरेंट, 25X है और 26S है, लेकिन है टाइटल दोनों का सेम है, ठीक है। मे बी ये सेक्रेटरी पर्सनल डिपार्टमेंट में और बाद में सेक्रेटरी अकाउंटिंग डिफरेंट डिपार्टमेंट में, क्योंकि सेक्रेटरी पोजीशन थी इसलिए डिफरेंट जॉब्स हो गई। तो यहाँ पे भी आपने देखा कि ये कुछ रोज हैं जिनमें आइडेंटिकल डेटा जो है वो प्रेजेंट है इन सम फील्ड्स। इसको ये इस सब की रिडंडेंसी हटाने के लिए या इस सब की ये वाला जो सिचुएशन है इसको खत्म करने के लिए हम ये कर सकते हैं कि हम डिफरेंट रिलेशंस बना दें, बजाय इसके कि सारी इंफॉर्मेशन एक ही रिलेशन या एक ही टेबल के अंदर। अब ये कर सकते हैं कि हम डिफरेंट टेबल्स बना दें, ठीक है, जैसे कि इसमें हमने तीन टेबल बना दिए, ठीक है, एक हमने एम्प्लॉय टेबल बना दिया या एम्प्लॉय रिलेशन, एक हमने जॉब रिलेशन और एक असाइनमेंट रिलेशन, तीनों। अब एम्प्लॉय रिलेशन में वो इंफॉर्मेशन है जो एम्प्लॉय से रिलेटेड है, और उसमें और कोई चीज नहीं है इस टेबल में। तो इसका फायदा ये होगा कि इसमें कोई भी ऐसा आप नहीं देखेंगे कि रोज जहाँ पे वो डुप्लीकेट हो रहा है इंफॉर्मेशन, ठीक है। जो बेकर सिर्फ एक रो में है और क्लार्क भी एक में है और स्मिथ भी एक में है, ठीक है, क्योंकि इनका एड्रेस जो है वो वन एड्रेस है वन एम्प्लॉय का, और वन सोशल सिक्योरिटी नंबर है या ERP नंबर है वो भी एक है। तो इसलिए इसमें इसको स्प्लिट करने से टेबल को ये फायदा हुआ। इसी तरह से जॉब का रिलेशन जो है, जॉब आईडी जो है ये कौन से डिपार्टमेंट में होती है और इसका क्या टाइटल होता है, ये अलग कोड में। अब इन दोनों को लिंक करने के लिए ये वाला एम्प्लॉय जो था इसके पास ये जॉब थी, एक हमारे पास एक तीसरा रिलेशनशिप हमें चाहिए होगा, जो कि पहले हमें इसकी जरूरत नहीं थी क्योंकि एक ही टेबल में ये सारा डेटा था, लेकिन अब हमने क्योंकि स्प्लिट कर दिया है तो अब हमें ये पता करना पड़ेगा कि भाई कौन सा एम्प्लॉय कौन सी जॉब करता रहा और कब से कब तक रहा। तो वो जो असाइनमेंट है वो अलग टेबल में चली जाएगी। ये वाला एम्प्लॉय जो है इसके पास ये वाली जॉब थी, उसने इस वक्त को स्टार्ट की थी। अब इसमें देखिए कि एम्प्लॉय का सिर्फ आईडी है, बाकी डेटा नहीं है, उसका नेम एड्रेस और नंबर नहीं है। इसी तरह जॉब सिर्फ आईडी है, उसका टाइटल, स्किल कोड और डिपार्टमेंट नहीं है। क्योंकि हमें सिर्फ यही दो जो है आईडीज चाहिए वो लिंक बनाने के लिए, कौन सा एम्प्लॉय कौन सी जॉब कर रहा था उसके लिए लिंक करने के लिए सिर्फ उनकी आईडीज हमें। अब इस लिंक के अपने कुछ एट्रीब्यूट्स हैं। मिसाल के तौर पे जब एक एम्प्लॉय एक जॉब शुरू करता है तो उसकी एक स्टार्टिंग डेट होती है और उसकी एक एंड डेट होती है, ठीक है। अब ये स्टार्टिंग डेट और एंड डेट जो है, इट इज नॉट स्पेसिफिक टू एन एम्प्लॉय। कोई भी एम्प्लॉय किसी वक्त भी शुरू कर सकता है, ठीक है। एंड इट्स नॉट स्पेसिफिक टू जॉब, यानी कि कोई एक जॉब है उसको कोई किसी वक्त भी शुरू कर सकता है। तो ये ऐसा नहीं है कि भाई जो सेक्रेटरी की जॉब है वो हमेशा 1 जनवरी से शुरू होगी, ऐसा नहीं होता, ठीक है। तो जब कोई एम्प्लॉय को साइन किया जाता है किसी जॉब में, उस वक्त से वो शुरू होती है। तो ये जो स्टार्ट डेट है इसका मतलब है ये असाइनमेंट का एट्रीब्यूट है, इट्स नॉट द एट्रीब्यूट ऑफ द एम्प्लॉय एंड इट्स नॉट द एट्रीब्यूट ऑफ द जॉब, ठीक है। एट्रीब्यूट का मतलब होता है कि हमें, अगर हमें आईडी पता हो तो हमें उसकी वैल्यू पता चल जाए। मिसाल के तौर पे अगर हमें पता चल जाए कि कौन से एम्प्लॉय की बात हो रही है, तो हम ये तो नहीं बता सकते कि उसने कब वो ज्वाइन किया था जॉब, ठीक है। अगर हमें सिर्फ उसका एम्प्लॉय का आईडी पता हो, क्योंकि हो सकता है कि एम्प्लॉय जो है वो उसने वो जॉब मल्टीपल टाइम्स की हो, ठीक है, तो उसके मल्टीपल टाइम्स वो आ जाएंगे। इसी तरह से जो है एक जॉब जब है शुरू, जॉब कोई है, हम ये नहीं बता सकते कि भाई उसकी स्टार्टिंग डेट क्या है, क्योंकि इट डिपेंड्स ऑन कौन से एम्प्लॉय ने स्टार्ट किया, उस पर डिपेंड करेगा उसका। जॉब से उसका कोई ताल्लुक नहीं है, उसका ताल्लुक ऐसे कि वो कौन सा एम्प्लॉय है तब उसके स्टार्ट। इसका मतलब है कि अगर हमें जॉब आईडी पता है तो हम ये नहीं बता सकते कि स्टार्ट डेट क्या है, क्योंकि इट्स नॉट मीनिंगफुल टू आस्क के भाई इस जॉब की स्टार्टिंग डेट क्या है। इसका मीनिंग उसी वक्त आता है जब कोई एम्प्लॉय शुरू करता है उस जॉब को, ठीक है। तो व्हेन वी हैव दिस टू पीसेस ऑफ इंफॉर्मेशन कि कौन सा एम्प्लॉय कौन सी जॉब कर रहा है, तब हमें स्टार्ट डेट का जो है कॉन्सेप्ट जो है वो क्लियर होता है। So that's why this attribute goes to the third table, not first or second table. ठीक है, is this concept clear कि ये start date जो है वो इस assignment टेबल में क्यों आ रही है? All right. Any other question regarding DVMS so far? No questions, then we can go a little bit further. Okay. तो ये एक नया कॉन्सेप्ट अभी यहाँ पे आपको नजर आ रहा है, इट्स कॉल्ड ER डायग्राम। ER डायग्राम जो है वो डेटाबेस को डिजाइन करने का एक तरीका होता है, ठीक है। एक टूल है ये, एक खास तरह की इसमें कन्वेंशंस शामिल होती हैं। और इसमें इसमें अगर आप देखें कि कुछ चीजें आपको जानी पहचानी लग रही होंगी, जैसे कि हमने यहाँ पे एक एग्जांपल है जिसमें एक कस्टमर जो है किसी दुकान से कोई प्रोडक्ट खरीदता है या ऑर्डर करता है, ठीक है। आप ऑनलाइन ऑर्डर करते हैं, दराज से कोई चीज खरीदते हैं, ठीक है। तो अगर दराज से कोई चीज खरीदते हैं तो एक तो हमें इंफॉर्मेशन चाहिए अबाउट कस्टमर कि किस कस्टमर ने वो ऑर्डर किया, ठीक है। दूसरी इंफॉर्मेशन हमें चाहिए कि प्रोडक्ट के बारे में, कौन सी प्रोडक्ट जो है ऑर्डर की गई है। और तीसरी इंफॉर्मेशन जो है वो इन दोनों का लिंक है कि कौन से कस्टमर ने कौन सी प्रोडक्ट जो है वो परचेज, क्योंकि एक कस्टमर जो है वो बहुत सारी प्रोडक्ट्स जो है वो परचेज कर सकता है, ठीक है। और सिमिलरली एक प्रोडक्ट को बहुत सारे कस्टमर्स परचेज कर सकते हैं। मिसाल में कस्टमर 1 जो है वो प्रोडक्ट 1 और प्रोडक्ट 2 और प्रोडक्ट 3 खरीदता है, ठीक है। एक कस्टमर काफी सारी प्रोडक्ट्स खरीद सकता है, तो लेट्स से वो 1 2 3 खरीद रहा है। दूसरा कस्टमर है दूसरा कस्टमर है वो भी प्रोडक्ट 1 खरीद रहा है और प्रोडक्ट 2 भी खरीद रहा है, लेकिन प्रोडक्ट 3 नहीं खरीद रहा, बस जो है प्रोडक्ट 4 खरीद रहा है। तो कस्टमर नंबर 2 जो है वो प्रोडक्ट 1 2 और 4 खरीद रहा है, ठीक है। इससे कस्टमर 3 हो सकता है प्रोडक्ट 9 10 एंड 11 खरीद, ठीक है, क्योंकि ज़ाहिर बहुत सारी प्रोडक्ट्स हैं और हर कस्टमर की अपनी चॉइस हो सकती है कि कौन सी खरीदनी। हो सकता है एक कस्टमर हो जो सिर्फ एक प्रोडक्ट खरीद रहा हो, ठीक है, प्रोडक्ट नंबर 15, और कोई प्रोडक्ट ना ले रहा हो। और प्रोडक्ट्स का भी जो है कस्टमर के साथ यही रिलेशन होगा। फॉर एग्जांपल जो प्रोडक्ट 1 है وہ ہمیں پتہ ہے کہ کسٹمر 1 نے خریدا ہے, کسٹمر 2 نے خریدا ہے, ہو سکتا ہے کسٹمر 99 نے بھی خریدی ہو سکتا ہے کسٹمر 200 نے بھی خریدی ہو, ٹھیک ہے. تو ایک پروڈکٹ کو بہت سارے کسٹمرز خرید سکتے ہیں اور ایک کسٹمر بہت ساری پروڈکٹس خرید سکتا ہے. تو یہ 1:many ریلیشن شپ ہے بٹوین کسٹمرز اینڈ پروڈکٹس. لیکن ان کو جو ٹائی کرتا ہے دونوں کو, ٹھیک ہے, کون سے کسٹمر نے کون سی پروڈکٹ خریدی, وہ آرڈر ایک اینٹی ہے جو کہ ان دونوں کو ٹائی کرتی ہے. وہ آرڈر کے اندر یہ انفارمیشن ہوتی ہے کون سا کسٹمر ہے, کون سی پروڈکٹ ہے, اس کی کتنی کوانٹٹی خریدی ہے, اس نے کس پرائس پہ خریدی ہے, اور وہ کب آرڈر جو تھا پلیس کیا گیا تھا اور اس کو ڈیلیور کب کیا گیا. تو یہ والی انفارمیشن جو ہے یہ آرڈر اینٹی ہے جس کے اندر ہونی چاہیے, ٹھیک ہے. یہ پروڈکٹ ٹیبل کے اندر یہ ہم نہیں رکھ سکتے انفارمیشن, کیونکہ ہمیں جو ہے ایک ہی پروڈکٹ کے سامنے بہت سارے کسٹمرز کے نام لکھنے پڑیں گے, ٹھیک ہے. تو وہ ہمیں نہیں پتا وہ ایک پروڈکٹ کتنے کسٹمرز نے خریدی ہے, 2 نے خریدی ہے, 10 نے خریدی ہے, 50 نے خریدی ہے. تو وی کی ناٹ ڈیزائن اے ٹیبل جس میں پہلے سے ہر پروڈکٹ کے سامنے اس کے کسٹمر نیمز ہمارے پاس جو ہے فیلڈ ہم نے رکھا ہوا, بیکاز وی ڈونٹ نو ہاؤ مینی کسٹمرز بائی دیٹ پروڈکٹ. اسی طرح سے ہر کسٹمر کے سامنے ہم پروڈکٹ فیلڈز نہیں رکھ سکتے, بیکاز وی ڈونٹ نو ہاؤ مینی پروڈکٹس دیٹ پرسن ول بائی, ٹھیک ہے, ان 1 day, in 1 month, in 1 year. ہم پہلے سے سارے فیلڈس تو نہیں بنا سکتے. تو اس لیے جو کسٹمر انفارمیشن ہے وہ صرف وہ انفارمیشن ہے جو فکس رہے گی, ول ناٹ چینج ود ایوری آرڈر, ٹھیک ہے. فار ایگزامپل کسٹمر کا فرسٹ نیم, لاسٹ نیم اور موبائل نمبر یا کوئی اور آئیڈینٹیفیکیشن نمبر, وہ ایسی فکس چیز ہے کہ وہ once you enter it will remain the same, ٹھیک ہے, unless the very rare chance کہ کوئی آدمی کہے کہ میں نے اپنا نام ہی چینج کر لیا, اخبار میں اشتہار دے کے اپنا نام نیا کروا لیا, اس کیس میں تو ہو سکتا ہے آپ کو جا کے اسے اپڈیٹ کرنا پڑے نام کو. لیکن موسٹلی لوگ ایسا نہیں کرتے. موسٹ آف دا ٹائم جب آپ کا فرسٹ نیم لاسٹ نیم جو ہوتا ہے وہ وہی رہتا ہے شروع سے لے کے آخر تک, ٹھیک ہے. آپ کے اسکول کے ریکارڈ میں بھی وہی ہوتا ہے, آپ جب امپلائمنٹ شروع کرتے ہیں وہاں پہ بھی ہوتا ہے, نادرا میں بھی وہی ہوتا ہے, پاسپورٹ پہ بھی وہی ہوتا ہے. تو ابھی اٹ ڈزنٹ چینج دیٹ آفن. اسی طرح سے جب پروڈکٹس ہوتی ہیں ان کی ایٹریبیوٹس بھی زیادہ چینج نہیں ہوتے, ٹھیک ہے. کچھ پروڈکٹس کے جو ایٹریبیوٹس ہیں کہ اس کا نام کیا ہے پروڈکٹ کا, ٹھیک ہے, اس پروڈکٹ کی کون سی ٹائپ ہے, ٹھیک ہے, اس کے اور کوئی ہو سکتا ہے کوئی ایٹریبیوٹس جو ہوں, جیسے کلر ہو سکتا ہے یا کوئی اور ہو سکتا ہے کس مٹیریل کا بنا ہوا وغیرہ وغیرہ. So there will be some attributes of the product that will not change with every order. Every time somebody buys it, اس کا نام چینج نہیں ہوگا, اس کا نام سیم رہے گا. فار ایگزامپل اگر کیمرہ ہے تو کیمرے کا اپنا ایک نیم ہوتا ہے, اس کا پلیس آف مینوفیکچرنگ ہوتی ہے, کہاں پہ وہ بنا ہے وغیرہ. جو آرڈر ہے یہ ایک ایسی اینٹی ہے جو کہ it comes into existence whenever a customer places an order, ٹھیک ہے. اور اس آرڈر کی جو انفارمیشن ہوتی ہے it only needs the customer ID and it only needs the product IDs, ٹھیک ہے. اس کے بعد جو ہے جو اس کے اپنے ایٹریبیوٹس ہوتے ہیں آرڈر کے, وہ ہوتے ہیں کہ ڈیٹ ہے فار ایگزامپل کہ کب یہ آرڈر پلیس کیا گیا, ٹھیک ہے, اس کا ٹوٹل کیا تھا اس آرڈر کا. تو یہ اس کے اپنے ایٹریبیوٹس ہیں. تو یہاں پہ آپ دیکھیں یہ جو میں ابھی تک ڈسکشن کر رہا تھا اس میں تین چیزوں کی بات کی ہے. ایک میں نے اینٹیز کی بات کی ہے, میں نے 3 اینٹیز کی بات کی ہے. ایک کسٹمر اینٹی کی بات کی ہے, ایک پروڈکٹ اینٹی کی بات کی ہے, میں نے ایکچولی 2 ہی کی ہے, ٹھیک ہے, کسٹمر اور پروڈکٹ کی 2 کی. اور میں نے ان کے ایٹریبیوٹس کی بات کی ہے, وہ انفارمیشن جو چینج نہیں ہوتی. فار ایگزامپل لاسٹ نیم, فرسٹ نیم اور کسٹمر آئیڈینٹیفیکیشن, یہ جو ہے چینج نہیں ہوگا. تو یہ جو 2 اینٹیز ہیں, یہ شروع میں جو ای ہے اٹ اسٹینڈس فار اینٹی, ٹھیک ہے. تو 2 اینٹیز ہیں اس میں, کسٹمر اور پروڈکٹ, اور اس لیے آپ دیکھ سکتے ہیں کہ یہ ان کو ہم ریکٹینگل سے ریپرزینٹ کریں. تو آپ پورے ڈائگرام میں دیکھیں there are 2 rectangles only. These are the entities. There are 2 entities, so therefore there are 2 rectangles in over here. Then there are rounded rectangles. Rounded rectangles جو ہیں وہ attributes ہوتے ہیں. یہ attributes یہاں پہ. تو attributes جو ہوتے ہیں ये राउंडेड रेक्टेंगल से हम शो करते हैं. तो हर एंटिटी के अपने एट्रीब्यूट्स होंगे. ठीक है, कस्टमर के हमारे पास 3 एट्रीब्यूट्स थे, फर्स्ट नेम, लास्ट नेम और आईडी. और इसी तरह से प्रोडक्ट के भी हमारे पास 3 एट्रीब्यूट्स थे, उसका कलर, उसका नेम और उसका आईडी. एंड देन देयर वाज अ रिलेशनशिप बिटवीन कस्टमर्स एंड प्रोडक्ट्स, और रिलेशनशिप को हमने एक डायमंड से शो किया. तो ER में E जो है वो रिलेशनशिप है, और सॉरी E जो है वो एंटिटी है, R जो है वो रिलेशनशिप है.
Sir, I had a question.
जी, what's the question?
Sir, I cannot understand the difference between entities and attributes.
अच्छा देखिए, बहुत आसान सा डिफरेंस है. आप में और आपके नाम में क्या डिफरेंस है, आप बताएं. Where is the difference? Do you see any difference between yourself and your name?
I'm a person and my name is my identity.
Yes, so you are a person, and your name is just one of the attributes that you have. ठीक है, आप में आपके जो है और एट्रीब्यूट्स हैं बहुत सारे. एड्रेस जो है आपका, फॉर एग्जांपल करंट एड्रेस, वो आपका एट्रीब्यूट है. ठीक है, और आपकी एज जो है वो भी आपका अपना एट्रीब्यूट है. बट दीज थिंग्स आर नॉट यू. ठीक है, आपकी एज is your attributes, it's not you. आपका नाम जो है it's an attribute but it's not you. आपका एड्रेस जो है वो आपका एक एट्रीब्यूट है या प्रॉपर्टी है, but it's not you. तो हर एंटिटी की अपनी प्रॉपर्टीज होती है. ठीक है, उन प्रॉपर्टीज को हम एट्रीब्यूट्स कहते हैं. ठीक है, फॉर एग्जांपल एक कार है, तो कार एंटिटी है, लेकिन उसके एट्रीब्यूट्स जो हैं वो होंगे कि भाई इसका मॉडल क्या है, ठीक है, इसमें कितने माइलेज हो चुकी है अभी तक, वो उसके एट्रीब्यूट्स हैं. ठीक है, उसका कलर क्या है गाड़ी का. तो ये सारी इसकी जो प्रॉपर्टीज होती हैं जो हम किसी एंटिटी के बारे में रख सकते हैं, उनको हम एट्रीब्यूट्स कहते हैं. तो हर एंटिटी की अपनी प्रॉपर्टीज होती है. फॉर एग्जांपल अगर एक बिल्डिंग है, तो बिल्डिंग की अपने एट्रीब्यूट्स होंगे. ठीक है, कि मिसाल के तौर पे कितनी बड़ी बिल्डिंग है, कितनी स्टोरीज हैं उसके अंदर. ठीक है, अगर एक हमारे पास किताब है, तो किताब के एट्रीब्यूट्स होंगे कि इस किताब क्या टॉपिक क्या है, किस टॉपिक पे ये लिखी गई है. ठीक है, दूसरा एट्रीब्यूट हो सकता है कि इसके नंबर ऑफ पेजेस कितने हैं, ये एट्रीब्यूट हो सकता है वगैरह वगैरह. ठीक है, और ये एक और एट्रीब्यूट हो सकता है कि ये हार्ड बाउंड है या ये सॉफ्ट कवर है, एक एट्रीब्यूट हो सकता है. तो एट्रीब्यूट ऐसी चीज है कि जो डिफरेंट एंटिटीज शेयर कर सकती हैं, बल्कि शेयर करती हैं. ठीक है, हर किताब को आप बता सकते हैं कि वो हार्ड कवर है या सॉफ्ट कवर है, और हर किताब का आप टॉपिक बता सकते हैं. लेकिन एक किताब का जो है अपना एक सेट ऑफ एट्रीब्यूट्स होता है जिसमें उसकी वैल्यूज होती है. ठीक है, जैसे कि अगर एक पेंसिल है, तो उसका एक एट्रीब्यूट हो सकता है कि कलर. ठीक है, तो अब डिफरेंट पेंसिल्स होंगी, तो सबका एट्रीब्यूट कलर सबका होगा, लेकिन उस कलर की वैल्यू जो है वो डिफरेंट होगी. ठीक है, किसी का कलर रेड होगा, किसी का ब्लू होगा, किसी का ग्रीन होगा, लेकिन हम उनको कहेंगे कि ये एक ही प्रॉपर्टी है जिसकी हम बात कर रहे हैं, कि व्हाट इज द कलर ऑफ दिस पेंसिल. तो कलर जो है वो एट्रीब्यूट है पेंसिल का. पेंसिल इज द नेम ऑफ द एंटिटी एंड कलर इज एट्रीब्यूट. और डिफरेंट पेंसिल्स के डिफरेंट कलर्स होंगे, कोई कलर ब्लू होगा, कोई कलर. तो जो ब्लू है ये वैल्यू है, वैल्यू ऑफ दैट एंटिटी. ठीक है, तो जैसे यहाँ पे लास्ट नेम जो है ये एट्रीब्यूट है, लेकिन इसकी वैल्यू जो है लास्ट नेम की वो हो सकती है वो लेट्स से ठीक है, ठीक है, ये जो वैल्यू है, ये रजा जो है, ये दिस इज द वैल्यू. ठीक है, लेकिन जो एट्रीब्यूट है उसका नाम है लास्ट नेम. ठीक है, इसका एक तरह से आप समझ सकते हैं कि ये कॉलम की हेडिंग है. कॉलम की हेडिंग जो है उस पर लिखा हुआ है लास्ट नेम, और उसके अंदर जो नीचे हेडिंग के नीचे लिखे हुए हैं वो लिखा हुआ है रजा, और किसी रो में लिखा होगा احمد, کسی روز میں لکھا ہوگا مسعود. تو یہ جو پوری رو ہے, the whole row is called the customer. ٹھیک ہے, the table, ایک تو سمجھ لیں کہ میں اس کو یہاں پہ اگر اپنی وہاں پہ چلا جاتا ہوں وائٹ بورڈ پہ. ٹھیک ہے, تو ہمارے پاس اگر ایک ٹیبل ہے تو ٹیبل پہ ایک ہیڈنگ ہوتی ہے. ٹھیک ہے, تو ہیڈنگ میں بھی ہم کچھ لکھتے ہیں کہ کیا ہیڈنگ ہے. ٹھیک ہے, فار ایگزامپل ہم نے ہیڈنگ میں لکھ دیا ERP اور نیچے لکھا ہے 1 2 3 اور دوسری رو میں لکھا ہے ہم نے 4 5 6. تو 1 2 3 جو ہے is the value of attribute called ERP. اب ERP جو ہے, ERP نمبر, اس کو ERP نمبر میں کر دیتا ہوں. ERP number is an attribute of an entity called student. ٹھیک ہے, تو یہ اسٹوڈنٹ ایک کنسپچل اینٹی ہے. ٹھیک ہے, ہر کنسپچل اسٹوڈنٹ کا ایک ERP نمبر ہوتا ہے. لیکن اگر ہم کسی اسپیسیفک اسٹوڈنٹ کی بات کریں, ایک انسٹنس کی بات کریں, یعنی کہ ایک رو کی بات کریں, ہم پورے ٹیبل کا کنسپچلی ٹیبل کی بات نہیں کریں. کنسپچلی ہم اس طرح سے لکھتے ہیں کہ یہ اسٹوڈنٹ جو ہے ایک اینٹی ہے اور اس کے ایٹریبیوٹس ہیں ERP اور نیم اور ایڈریس. ٹھیک ہے, تو یہ جو میں نے لکھا ہے یہ ایک کنسپچل اینٹی کو میں نے ڈیفائن کیا. کنسپچل اینٹی کا نام اور اس کے ایٹریبیوٹس, 3 ایٹریبیوٹس ہیں. لیکن اگر میں کسی ایک اسپیسیفک اسٹوڈنٹ کی بات کروں, ٹھیک ہے, تو اگر میں یہ کہوں کہ یہ ایک اسٹوڈنٹ ہے 1 2 3 رضا کراچی. ٹھیک ہے, تو یہ اب میں نے ویلیوز جو ہیں اس کے اندر انٹر کر دیا. تو اب جب میں نے ویلیوز انٹر کر دی تو اس کا مطلب ہے میں ایک اسپیسیفک اسٹوڈنٹ کی بات کر رہا ہوں, ایک اسٹوڈنٹ کی بات کر رہا ہوں. میں پوری کلاس کی کنسپچلی میں اسٹوڈنٹ کی بات نہیں کر رہا ہوں. میں صرف ایک انسٹنس کی بات کر رہا ہوں, ایک اسپیسیفک انڈیویجول ریئل پرسن کی بات کر رہا ہوں. ناٹ کنسپچلی کہ ہاں جو بھی اسٹوڈنٹ ہوتا ہے اس کا ایک ERP نمبر ہوتا ہے, اس کا نام ہوتا ہے, اس کا ایڈریس. ٹھیک ہے, جب میں کنسپچلی بات کرتا ہوں کہ بھائی اسٹوڈنٹ ایک اینٹی ہے اور جس کا ERP نمبر ہوتا ہے, نام ہوتا ہے اور ایڈریس ہوتا ہے, اور وہ ہم سارے اسٹوڈنٹس کا ڈیٹا ایک ٹیبل میں رکھتے ہیں, تو وہ میں کنسپچلی اینٹی اسٹوڈنٹ کی بات کر رہا ہوں. لیکن جب میں ویلیوز اس میں کے حوالے سے بات کرتا ہوں تو میں ایک انسٹنس یا اسپیسیفک رو یا ایک میں اسپیسیفک اسٹوڈنٹ کی میں بات کر رہا ہوں. ٹھیک ہے, تو اس ریلیشن شپ کو شو کرنے کے لیے ہم جو ڈائیگرام یوز کرتے ہیں وہ ہم ERP ڈائیگرام یوز کرتے ہیں. ERP ڈائیگرام میں ہم اینٹیز اور ایٹریبیوٹس اور ان کے ریلیشن شپس کو الگ الگ شو کرتے ہیں. ٹھیک ہے, اینٹیز کو ہم ریکٹینگل سے شو کرتے ہیں, ایٹریبیوٹس کو ہم راؤنڈڈ ریکٹینگل سے شو کرتے ہیں, اور ریلیشن شپس کو ہم شو کرتے ہیں ود ڈائمنڈس. ٹھیک ہے, اور یہ جو اس میں لائنز ہوتی ہیں وہ ہمیں بتاتی ہیں کہ یہ کس طرح کے ریلیشن شپ ہیں اس کے بیچ میں. Alright, so that's all for today. It's a design like flow chart in programming. It's not a flow chart because اس میں یہ structure dynamic نہیں ہوتا, اس میں کوئی ہم سیکوینس کا کانسیپٹ نہیں ہوتا. It's a static structure. ٹھیک ہے, یہ ڈیٹا ہے, یہ اس کا ایٹریبیوٹس ہیں, یہ ان کے ریلیشن شپ ہے. So it's a static structure of the database جس کے اندر ڈیٹا جا کے اسٹور. ٹھیک ہے, so this is a diagram. This is very helpful, and اس کو میں next class میں آپ کو بتاؤں گا کہ کس طرح سے اس کو یوز کرتے ہیں یہ diagram. So that's all for today. Thank you very much, and I'll see you next time.